Right, let's do some physics. GCSE Physics Foundation Tier paper by AQA. All the physics on all the papers are very similar. It doesn't matter what exam board you're doing. So you should find this helpful. Right, energy resources can be renewable or non-renewable. Coal is a non-renewable energy resource. Name 2 other non-renewable energy resources. Non-renewable, that means things that are going to run out. So you've got oil, and you've got natural gas. You could also have nuclear. They are the 4 non-renewable energy resources, along with coal there. Wind turbines are used to generate electricity. Figure 1 shows how the power output of a wind turbine changes over one day. So there's midnight, I guess, 4 o'clock in the morning, 8 o'clock in the morning, noon, 4 o'clock at night, 8 o'clock at night, midnight again. And you can see the power output in megawatts, which means millions of watts. You can see how it's going up and down. At this point here, it's not producing any power, and then it comes up again there. Right, the question. A wind turbine does not generate electricity constantly. For how many hours does the wind turbine generate no electricity? Well, that was this period here. So hang on, 0 and 4 is represented by 10 squares. So that must be 2 o'clock, 4 o'clock. Right, so here, if that's 12 o'clock, that'll be 2 o'clock. So at 2 o'clock, there's no power. 4 o'clock, 6 o'clock. So from 2 till 6, so that's 4 hours. So the wind turbine does not generate electricity constantly. For how many hours does the wind turbine generate no electricity? The answer is 4 hours. A wind turbine has a maximum power output of 2 megawatts. How many watts are there in 2 megawatts? That's 2 million watts. An island has a large number of wind turbines and a coal-fired power station. The island needs to use the electricity generated by the coal-fired power station at certain times. Choose one reason why. Wind is a renewable energy resource. Wind turbine power output is constant. No, it's not. The power output of wind turbines is unpredictable. Yes. If you relied solely on wind, well, what if it's not windy? You'll have no power. The fuel cost for wind turbines is very high. That's not important. Figure 2 shows a student before and after a bungee jump. The bungee cord has an unstretched length of 20 meters. So this is before, on top of the bridge. This is after. For safety reasons, it is important that the bungee cord used is appropriate for the student's weight. Give 2 reasons why. The bungee rope might snap, and the person could injure themselves, or the person could dunk into the river. The student jumps off the bridge. Complete the sentence to describe the energy transfers. Before the student jumps from the bridge, he has a store of, well, it'll be gravitational potential energy because he's up high. When he is falling, the student's kinetic energy increases. When the bungee cord is stretched, the cord stores energy as elastic potential energy. I would actually write them in. I wouldn't do that in an exam, mind. At the lowest point in the jump, when the student is stationary, the extension of the bungee cord is 35 meters. The bungee cord behaves like a spring with a spring constant of 40 newtons per meter. Calculate the energy stored in the stretched bungee cord. Use the correct equation from the physics equation sheet. Energy equals a half kx squared. So k is the spring constant, x is extension. So that's a half times by 40 newtons per meter times by 35 meters squared, and that equals 24,500 joules. Question 3. A student wants to investigate how the current through a filament lamp affects its resistance. Use the circuit symbols in the box to draw a circuit diagram that she could use. So you want to get the current through a filament lamp. Now, if it's going to affect its resistance, Ohm's law is V equals I times by R. So therefore R, resistance, equals the voltage over the current. So we'll need to measure the voltage with the voltmeter, measure the current with the ammeter, now you could just adjust the voltage by using the power pack, or you could adjust the voltage and current by using a variable resistor. By changing the size of the variable resistor, you'll change the current and the voltage. So get 6 readings of current and voltage. Part 2. Describe how the current could use her circuit to investigate how the current through a filament lamp affects the resistance. Adjust current through circuit by adjusting the variable resistor. Get 6 different readings of I and V. Calculate resistance by using I equals V over I. The student's results are shown in figure 3. Describe how the resistance of the filament lamp changes as the current through it increases. So as the current is getting bigger, the resistance is getting bigger. It's not a straight line, so it's not proportional. It's only worth 1 mark, so that's enough. Use figure 3 to estimate the resistance of the filament lamp when a current of 0.1 amp passes through the lamp. So there's 0.1 amp there. If we just follow the graph back, it's going to be something like that. So if that's 6, that'll be 7 there, and then it's 8. So it's somewhere between 6 and 7, probably about 6.5. They'll accept a range. As long as you show what you've done on the graph, that'll help the examiner to tell whether you've got the mark or not. The current potential difference graph of 3 components are shown in figure 4. Use answers from the box to identify each component. Well, this is a filament lamp, otherwise known as a bulb, but as I say to the kids I teach, imagine it's called a spurb because it's an S shape. This is a ohmic resistor, so it's a resistor at constant temperature. I've said ohmic resistor just in case they have that as an option next time. And this is a diode. A diode does not let current go in the reverse direction, it only lets current go in the forward direction. It always takes a little bit of voltage there as well, about 0.6 volts, before the current does start to flow in a positive direction. Which graph in figure 4 shows that current is directly proportional to the potential difference? Give a reason to your answer. It was graph B, the resistor at constant temperature. And that's because the current is proportional to the voltage. And that's because the graph was a straight line that passes through the origin. The origin is 0, 0. 4. 2 students investigated the change of state of stearic acid from liquid to solid. They measured how the temperature of stearic acid changed over 5 minutes as it changed from liquid to solid. So student A has used a data logger with a temperature probe that goes to 1 decimal place. Student's B apparatus, he's just using a thermometer, which is very difficult to see accurately. There's not as high a resolution on that as there is on the data logger. Choose 2 advantages of using student A's apparatus. Tick 2 boxes. Student A's apparatus made sure the test was fair. Nope. Student B's apparatus only measured categoric variables. No. Student A's measurements had a higher resolution. Yes. Student B was more likely to misread the temperature. Well, yeah, it's very difficult to say exactly what the temperature is, so the answer is those 2. Student B removed the thermometer from the liquid each time he took a temperature reading. What type of error would this cause? A random error. Student A's results are shown in figure 6. At what temperature did the stearic acid start to freeze? So this is the stearic acids, the temperature dropping. This is the change of state represented by the flat section, and then that's the temperature dropping again once it's changed state. So it started as a liquid, then this will be the part where it's freezing, and this is the part where it's a solid but it's getting colder. What temperature did the stearic acid start to freeze? It's that temperature there, which is 55.6. Yeah. Use figure 6 to determine the time taken for the stearic acid to change from a liquid to a solid. So from a liquid to a solid, it's going from about 150 up to 900. So that's 750 seconds. Again, they'll probably offer you a range there. After 1200 seconds, the temperature of the stearic acid continued to decrease. Explain why. Well, 1200 seconds. Temperature is still at 53.5 degrees-ish. That's not room temperature yet, so it's going to continue to decrease in temperature until it reaches room temperature. So the temperature will drop until it reaches room temperature, about 20 degrees C, room temperature. 5. An electrical circuit is shown in figure 7. Calculate the total resistance of the circuit. Well, these resistors are in series, so you just add them together. The potential difference across the 10 ohm resistor is 4 volts. Calculate the potential difference across the 20 ohm resistor. So if you've got 12 volts, it's going to get used up on that and that. So if it's saying on the 10, you've got 4 volts. How many volts have you got left? 8. So you'll have 8 volts on there. These two voltages have to equal that voltage. And another thing to notice, this resistor is twice as big as this resistor. So this resistor will get twice as much volts. So 4 doubled is 8, and then double check that 8 plus 4 equals 12. It does. Write down the equation which links current, potential difference, and resistance. That's Ohm's law. Voltage equals current times by resistance. So that's V equals IR. Calculate the current in the circuit in figure 7. So current I equals V over R. So it was 12 volts divided by 30 ohms, and that equals 0.4 amps. Because you want the current in the circuit, you need to know the resistance of the complete circuit. So that's why we've used 30. We didn't use 10, we didn't use 20. The current in the circuit is direct current. What is meant by direct current? Is it current that continuously changes direction? No, that's alternating current. Current that travels directly to the component? No. Current that is always in the same direction? Yes. 6. A student rubs an acetate rod with a cloth. Figure 8 shows the charges on the acetate rod and cloth before and after rubbing. So before, we've got a mixture of positive and negative charges on both the rod and the cloth. After, we seem to have more positive charges on the rod and more negative charges on the cloth. So it looks like electrons, the negative charges, have jumped from the rod onto the cloth. Explain how the friction between the acetate rod and the cloth causes the rod and cloth to become charged. Explain how the friction between the acetate rod and the cloth causes the rod and the cloth to become charged. So, friction causes electrons to be transferred, in this case, from the rod to the cloth. So the rod becomes negative and the cloth will become positive. After charging them, the student moves the acetate rod and the cloth closer together. Which statement is correct? There is no force between the acetate rod and the cloth. Nope. There is a force of attraction between the acetate rod and cloth. Could be. There is a force of repulsion. Right, okay, it's the attraction one then. Give a reason for your answer. Opposite charges attract. Figure 9 shows a Van de Graaff generator which is used to generate static electricity. See my video on Van de Graaff generators and static electricity. The link will be above. The longer the Van de Graaff generator is switched on, the more charge is stored on the metal dome. Complete the sentence. Use an answer from the box. The amount of charge on the metal dome is increased, which causes the potential difference between the metal dome and the Earth's sphere to increase. More charge creates more voltage. When the potential difference between the Van de Graaff generator and the Earth's sphere is 60,000 volts, a spark jumps between the metal dome and the Earth's sphere. The spark transfers that many coulombs of charge to the Earth's sphere. The equation which links charge, energy and potential difference, so that's just voltage, is that. Calculate the energy transferred by the spark. So the energy is going to equal the charge. Right, make sure you count the noughts correctly. So there's that many coulombs multiplied by 60,000 volts. And that's going to equal 1.5. Question 7. Figure 10 shows a balloon filled with helium gas. State 2 statements about the movement of the particles of helium gas inside the balloon. Okay, well, you can see some of them are fast, some of them are slow, and they are going all over the place. So it's random motion and it's a range of speeds. It's what we call rapid and random motion. What name is given to the total kinetic energy and potential energy of all the particles of helium gas on the balloon? That's called internal energy. The helium in the balloon has a mass of that. The balloon has a volume of that. The equation which links density, mass and volume is that. Calculate the density of the helium. So density equals mass over volume, and that equals 0.18, and I've took kilograms and I've divided it by meters cubed. So that's kilograms per meters cubed. Sometimes it could be in centimeters cubed. The helium balloon is released and rises into the sky. As the balloon rises, the air pressure around the balloon decreases. Describe how the volume of the balloon and the pressure outside the balloon change as the balloon rises. The volume of the balloon increases, and that's because there's less pressure outside of the balloon. So the pressure outside the balloon, that decreases because it told you that in the question. So you're not going to get a mark for that. So I'd better say what happens to the pressure on the inside of the balloon then. Well, if the pressure outside the balloon decreases, which makes the volume increase, that means that the pressure is going to decrease. And that's because as the volume increases, the particles have now got more space, so there's less collisions per second. And then that's basically what pressure is, how many collisions there are per second. 8. Alpha, beta and gamma are types of nuclear radiation. Draw one line from each type of radiation to what the radiation consists of. And that's for 3 marks. Alpha is 2 protons and 2 neutrons. Beta is an electron, but it's from the nucleus. And gamma is electromagnetic radiation. A teacher demonstrates the penetration of alpha, beta and gamma radiation through different materials. The demonstration is shown in figure 11. Complete figure 11 by writing the name of the correct radiation in the box. Well, alpha is stopped by paper. Beta goes through paper but gets stopped by aluminium. And gamma goes through paper, through aluminium, and needs a thick piece of lead to stop it. Standard question. Give 2 safety precautions the teacher should have taken in the demonstration. Well, they could wear safety glasses, they could wear gloves, they could handle the equipment, handle the radiation with tongs. Don't point the radiation at the students. Figure 12 shows how the count rate from the radioactive source changes with time. Complete figure 12 to show how the count rate would change between 160 and 320 seconds. We'll just keep following the trend. The half-life of the radioactive source used was 80 seconds. Show how figure 12 can be used to show the half-life. Well, the half-life is the time that it takes for the radioactive source for its count rate to decrease by half. So it started at 400 counts at a time of 0, so half of 400 is 200. So go along from 200 to the graph and come down here, and the half-life is 80 seconds. An electrician is replacing an old electric shower with a new one. The inside of the old shower is shown in figure 13. The electrician should not change the shower unless he switches off the mains electricity supply. Explain why. If he touches the live wire, it's going to send current through his body, so he could be electrocuted and that could kill him. The new shower has a potential difference of 230 volts and a current of 46 amps. Write down the equation which links current, potential difference and power. PIV, power equals current times by voltage. Calculate the power of the new shower. $10,580. The electrician installs a 45 amp circuit breaker in the shower circuit. Explain what will happen to the circuit breaker when the shower is switched on. 46 amps of current that the shower needs will make the 45 amp circuit breaker trip, and that will break the circuit and switch off the current. So your shower won't work. A fuse could have been used instead of a circuit breaker. Choose one advantage use of using a circuit breaker instead of a fuse. A fuse can be replaced. That's not an advantage. That's an inconvenience. A circuit breaker can be reset, yes. You don't need to change it. You just press the button on it and it'll reset it. Figure 14 shows an old house with a tiled roof and a single glazed windows. The house has solid stone walls and is heated using a coal fire. Describe how the householder could improve the energy efficiency of the house. Explain how your chosen methods reduce the rate of energy transfer to the surroundings. Right. Door. Put a draft excluder on the door to reduce convection. Loft insulation to reduce convection. Double glazing to reduce conduction and convection and radiation. Instead of a coal fire, put a new boiler in. The new boiler will have a higher efficiency than a coal fire. Reduce the temperature of the house, because if the house is closer temperature to the outside temperature, then energy won't be lost as quick. The national grid ensures that the supply of electricity always meets the demand of the consumers. Figure 15 shows how the output from fossil fuel power stations in the UK varied over a 24-hour period. There's the total power output in megawatts, so that's millions of watts, and that's Monday and Tuesday and the time. Suggest one reason for the shape of the graph between 3 and 6 on a Monday. So between 3 and 6, that'll be people getting home from work, coming in the house, putting the kettle on, putting the telly on, feeding the kids, things like that. So your house, the amount of power that you need to use increases because of all those things. At 6 o'clock on Monday, one power station stopped producing electricity. How does figure 15 show this? Well, the total power output decreased. The national grid ensures that fossil fuel power stations in the UK only produce about 33% of the total electricity they could produce when operating at a maximum output. Suggest 2 reasons why. That'll be to save the oil, coal and gas supplies, and also if there's another power station that has a fault, you'll be able to turn this power station up to meet the demand. It could also be to make sure if a renewable energy resource like wind, if that suddenly stops working, then this can meet the demand of renewable sources. A student investigated how much energy from the sun was incident on the Earth's surface at her location. Incident just means shines on. She put an insulated pan of water in direct sunlight and measured the time it took for the temperature of the water to increase by 10 degrees. The apparatus she used is shown in figure 16. So pan of water, thermometer in there, sun shining into it. The student could have measured the time taken for the water to increase in temperature by 1 degree C. Suggest one reason why the student's method was better. If you're only measuring an increase of 1 degree C, you might get it wrong by saying 0.1 degrees C's, which would be 10% error. Whereas if you are increasing by 10 degrees, you could still have the same error, 0.1 degree, but that would only be 1% error. The energy transferred to the water was 21,000 joules. The time taken for the water temperature to increase by 10 degrees was that many seconds. The specific heat capacity of water is that many joules. Write down the equation which links energy transferred, power and time. So energy transferred equals power times by time. Calculate the average power supplied by the sun to the water in the pan. Right, well, we'll rearrange that. So the power is the energy transferred divided by the amount of time. So that's 21,000 joules divided by 6,000 seconds. And that equals 3.5 watts. 1 watt is 1 joule per second. Calculate the mass of water the student used in her investigation. Use the correct equation from the physics equation sheet. So energy equals mass times by specific heat capacity times by temperature change. So we'll have to rearrange that. Delta theta means change in temperature. And that equals 0.5 kilograms. The student's results can only be used as an estimate of the average power at the location. Give 2 reasons why. Well, some of that energy would have been used to heat the pan. Some energy would have been lost to the surroundings. And maybe even the angle of the sun might have changed if it took a little bit of time for the pan to heat up. Question 13. A student investigated the efficiency of a motor using the equipment. Okay, so a motor's turning a pulley and it's lifting a mass or a weight because it put it down as newtons. He used the motor to lift a weight of 2.5 newtons, a height of 2 meters. He measured the speed at which the weight was lifted and calculated the efficiency of the energy transfer. He repeated the experiment to gain 2 sets of data. Give 1 variable that the student controlled in his investigation. Kept the same weight, kept the same height. Give 2 reasons for taking repeat readings in an investigation. Calculate a mean. Spot errors. Figure 18 shows a graph of the student's results. So efficiency up the side, percentage efficiency, speed along the bottom. Draw a line of best fit on the graph. What conclusions can be made from the data in figure 18? 3 marks. Right. Well, as the speed's increasing, the efficiency's increasing. It looks like there's going to be a speed limit. So there'll be a point at which the efficiency is not going to get any bigger. And I guess no efficiency can be more than 100%. Give one way that the motor is likely to waste energy, it'll get hot. Because of friction. If it was worth 2 marks, you'd say because of friction. The motor might make a sound as well, so that's sound energy. When the total power input to the motor was 5 watts, the motor could not lift the 2.5 newtons weight. State the efficiency of the motor. Well, something's efficient if it can do the job it's designed for. If that motor can't lift the weight, then it's 0% efficient. Because there's no useful energy. And that's the end of the question, so that's how to take care of that. I hope that's going to be useful for your exams, and good luck, work hard, be nice. Want to see more videos like this? Subscribe to my channel, GCSE Physics Explained. Thanks very much, and bye for now.